Good day, everybody. It's Danny Rains here again, back on the Voice of Experience. It makes me sound old when I say that. Uh, I actually did a class yesterday for a contractor, and we talked about this very subject. And the subject we're going to talk about is going to be regulations and arc flash. Of course, don't want to get too deep into it. I could talk for 2 hours, but I've only got about 20 or 25 minutes. So let me give you a little bit of overview of what to expect. This article will be in the February issue of Incident Prevention magazine, and it deals with a subject that's, near and dear to me and to all linemen, because it's one of those unknowns that we have to protect ourselves from. The irony to all of this is it's always been an issue, but there's never been a regulation really associated with the PPE and all of the things that are related to arc flash and arc blast. And what I'm going to try to do is define some of that stuff for us today, to where you can have a little bit more information, at least to ask the questions. Every month, David McPeak hosts IP Forum. That's 11 o'clock on the second Tuesday of each month, Eastern Standard Time. And we had one last Friday and talked about this subject came up. There's always questions comes up about arc flash, which is rightfully so. I was introduced to the knowledge of Hugh Hoagland back in the 90s, early 90s, with Southern Company Safety and Health. And basically, that's when arc flash then became an issue with me. And of course, I sought more knowledge. So I went to work with and worked for Hugh for years until he retired. And I still represent E-Hazard. I'm not a salesperson, but it's one of the best resources for arc flash you can get. Well, during that meeting last Friday, we had 47 people, I think, on there, right at 48, 49, something like that. And it's an opportunity to get on there and interact and also network with other safety and health professionals and other folks in the industry. And we all share the same concerns, especially when it comes to arc flash. One of the questions that comes up all the time, does NFPA 70E cover utility employees? And of course, I'm going to give you a political answer to that, yes and no. When you talk utility employees per se, and that is linemen on line crews, NFPA 70E really doesn't cover that. It's really the voluntary consensus standard for low voltage. And OSHA defines low voltage as 600 volts to down to 51 volts. So that consensus standard is the working group, the IEEE and other groups that actually come up with this information. And of course, the big difference between the low voltage and the high voltage standards is one don't work with the other one. So they wrote, the NFPA 70E for safe work practices. Article 120 being de-energized, locked out, tagged out. Best way to avoid an arc flash or shock hazard is to lock it out and tag it out. Check it for the absence of voltage, and you should be in pretty good shape. Not so true on utility-wise, because and that's why we have a different standard. We have induction corridors. We have a lot of induced voltages. We have feedbacks on systems that are out of our control if somebody doesn't do right. So there's other reasons. But really, when you get down to it, the safe work practices, which is found in Article 130 in the NFPA 70E, it has a lot of tables in there. It has a lot of information in there for electricians when working on industrial, commercial, or residential, projects and services. So when you look at it, the 1910-269, the high voltage standard, we have the NESC, the National Electrical Safety Code, which is our consensus standard. And much of the information found in the NESC is the same thing as we find in OSHA. When they finally, I guess, merged the committees together to a point to where, and in the timing of the cycles of the NESC, the 2017 came out after the 2014-15 update of 269. A lot of what's the safety rules in NESC say the same thing. It requires PPE, and PPE is defined now as ARC-rated FR clothing. I kid a lot of my classes when I'm talking to them, and I say, well, after the 94 269 came out, it told us what not to wear, but it didn't tell us what to wear. It just said there's a hazard there, but it never did define what the hazard was. Then the NESC went to work, and all the way back in 2002 and 2007 edition, they said, hey, we need to do an analysis and see just how bad the arc flash really is. And so that was a charge from that voluntary standard back in 2007 issue and cycle. And so, people scurried around and started doing a lot of engineering. A lot of software popped up, Arc Pro, 3-phase multiplier. SKM's another good one. IEEE 1084 works on some systems, not on others. It does now, since they've got it didn't work on the higher voltages for a long time. Not inaccurate. It worked, but not as accurate an estimate of the incident energy. And another big difference between low voltage and high voltage, you can use the low voltage and use the software and do the calculations either through the appendix in the NFPA 70E or using software or just do it the hard way. But you can pretty much nail it down. I mean, it gives you a lot of information there. It gives you, the working distances, it gives you the arc flash values, and then that way you know where to barricade at the furthest distance from the arc. There's a lot. Now, in the OSHA, what does it say in paragraph L of 1910-269? The employer must make a reasonable estimate of the incident energy. And of course, where is that at on our systems? That's at the low side bus of the power transformer sitting in the substation. And the further you get away from the substation, that value will decrease, which is it's kind of like a false message to us. Well, it's not that bad. But then again, too, you have all kinds of other issues you got to deal with. You have an arc flash, the incident energy may go down, the available fault current may go down, but you may not generate enough fault current to trip the system. So it's burning. The rule of thumb is the longer it burns, the hotter it gets. And that's kind of what I share with people as I do the classes. But getting back to the low voltage part, 137C, 15A and B, A is AC, B is DC systems, you can determine all of this information. What is the arc flash boundary? The arc flash boundary for low voltage is 1.2 cal centimeter squared. And basically what is that? That's enough heat energy to raise 1 gram of water 1 degree of Celsius. So when you say it's 1.2 cal, that's a significant burn injury that will cause a 2nd degree burn, a water blister. Well, the problem is it's defined in that low voltage, but when we get into high voltage and we get into substations or we get out working on primaries or transmission lines, those things, there's no table that we can go to. We got to do the engineering on it, or somebody has to do the engineering on it and do everything that's needed done to determine where that arc flash boundary is. Also, the arc flash boundary is determined 2 cal centimeter squared for high voltage on the 1910-269 standard. We wore cotton shirts and pants for years and years doing line work. I mean, my goodness, I worked, I stood in a bucket and glove 12 and 25 kV for years and, had nothing on but a cotton t-shirt and, 11-ounce denim jeans. And then all of a sudden we went to an FR shirt and then 11-ounce denim jeans. And then all of a sudden we said, oh, no, wait a minute. The information kept getting more and more. That was 70s and 80s and up into the 90s and then 2000s. And it's amazing how much information changed as time went by. Well, another question that came out of the IP forum last week was, how do we avoid arc flash? Well, proper cover up, removing three-phase exposure on a utility system is, if you keep it single phase to ground, it's a whole lot better than phase to phase, but none of them are good for us. We're not, I tell people all the time, we are nothing but 1,000 ohm resistor in an electrical circuit. That's all the human body is. And we're a good conductor of electricity, but we can't carry a lot of current. We certainly can't stand a lot of arc flash. So these regulations that's written are very vague and very ambiguous and ill-defined to a certain point. And that's because there's one regulation for our utility workers for all the utilities that's out there in the United States. Whether it's a Y, multi-ground Y, a 5-conductor Y, multi-ground, single conductor Y, a delta, we got one regulation that covers it all. So then who's it really up to determine all this information? Now, OSHA's not going to do it for us. They're just going to tell us what to do. They're not going to tell us how to do it. And that's the way it should be, because the employer, knowing their system, designing and engineering and maintaining that system, is ultimately responsible and accountable for the employees that's working on that system. So they got to do the engineering. They got to figure out where that magic boundary is of 2 cal centimeters squared, and then determine the level of PPE based on incident energy and arc flash. It gets a little complicated sometimes. It really does, and I totally understand it now better than I ever did in the days, I guess, when I was learning the system. And I certainly hadn't learned everything I need to know now, and I've been in it a long time. A third question came out, where is the most dangerous thing for a utility lineman on a distribution lineman? What's one of the most dangerous things you can do? Well, to me, based on the information, the engineering from EPRI and the BLS and all the other information where things has already happened and we get the information on it. And then the engineering group came up, the IEEE came up, did the testing back in 05 and 06. Before the standard was updated in 14, it determined we needed this PPE and what level. They did some testing and they found out a self-contained meter base, 240, 480, 277, 480, single phase or 3-phase, probably the most dangerous place we can actually manipulate things and make a flash occur, because it's really the closest thing to an industrialized, commercialized electrical system in a building called arc in the box. You're talking about a 5-sided device, okay, front, top, bottom, back, left side, front side. The only thing, the left side, right side, the only thing that's open is the front. So if we're setting a meter in a self-contained meter base and start a fire, either break a lug in a meter base or short something out somehow, this is a cannon shot. It's all coming straight out at the person standing in front of the meter base. Before the heat and the fire can go up, it's got to come out. So that is one of the most dangerous activities and tasks that we can perform there. So what kind of PPE do we need setting meters? Well, if it's a single phase 12240, it's very, very rare that it ever gets over about 6 to 8 calorie exposure. So, if we want to be ultimately safe with that, according to the standards now, you got to remember what the OSHA standard says about it. They give us a lot of leeway, but bearing in mind the OSHA regulations are the minimum, okay? The minimum work practices that will keep us safe. If we want to add to that, if the employer wants to add to that, that's fine. And that's a good thing. So, and I know a lot of people don't understand that. But when you're dressing out to set a meter, I tell people all the time on a 277 480 or a 240 480, single phase or a 3-phase, kill it. Don't even set it hot. If you got to, get an outage on it, prearrange an outage. and de-energize it. That's the Article 120 in the NFPA 70E. The best way to avoid a flash or electrical shock is to have it locked out and tagged out. So that's by far the best way. But when you're standing in front of a meter base and, you know, everything is measured on about an 18-inch reach, okay? And here's another thing about an arc flash that I want to share with you, especially on these medium or the 277 meter bases, 277 480. You know, we measure everything and testing in the industry at 18 inches arms length. So if something happens, what if you're looking up, got your face stuck up closer than 18 inches? You know, which is not unusual to look in to see the spades on a self-contained meter base or if it's a bolt-in or whatever. You know, now then, just remember this. This is just kind of a little table. This is something I learned years ago, that the distance and the heat are inversely proportionate to one another. If I've got 8 cal at 18 inches, what have I got at 9 inches? Probably 16 cal. So what have I got at 36 inches? I probably have 9 cal. So if I shorten it up by half, I double the incident energy. If I expand it to twice the 18 inches, gives it more room to expand and, you know, to have the quote open air, then all of a sudden, you know, it's less than that. So, but that's just one thing I'd really like for you to remember about meter bases. It's the most dangerous thing we can do. Even on that single phase 120 240, as I said, rarely does it ever get over 6 to 8 cal, but that 277 480 can go up to 20 cal. And it depends on the transformers, the impedance of the coils of the transformers, the size of the conductor, the length, all of that. That's what will determine the amount of exposure. Now, the next question, it really was discussed last Friday, was switching transformers, opening transformers, a single phase or a 3-phase. Many 3-phase live front transformers, and I don't know if you have any or not, but many of those things does not have that NESC required second barrier as a switching cubicle, like a PMH 6 or 7. They'll have you'll open that NEMA class steel door, which is the shock hazard, and then you got a fiber board in there. It says, hey, beyond this, it's got this voltage, and it'll usually have it stenciled on the fiberglass. So, you know, you look at that, and you're almost violating minimum approach when you open the door. Rule of thumb, what we used to practice, our practice at where I worked for 40 years, we would stay behind. If it was a live front transformer, we knew it, we'd stay behind the door. We'd remove the lock, take the captive bolt out, and then open the door, staying behind the door the whole time, just in case there's something in there that we didn't want to affect us. That way we'd still have that metal door between us and it. So you have to be very, very careful. Remove those panels with a stick. So when it's a dead front, elbows and bushings, that's always a controversial point right there, because these questions came up from some of the attendees last Friday. Those cables are insulated for the voltage that they're carrying. That is, if it's a normal, you know, in normal operating conditions. If there's damage, if there's lightning, if there's a question, if it's a single phasing event, if there's a swollen elbow or bushing, then now it's an abnormal event. You know, safest thing again to do is probably switch it and tag it out. You know, make sure that you switch it out, check for the presence, absence of voltage, and then maybe ground it, and then figure out what you're going to do with it before you even touch it. I always tell people, when you're running a case of trouble, use your senses, but let the sense of touch be the last one. If you can see it, smell it, or hear it, there's something else going on. If you touch it, it may be sitting there on a wing and a prayer and fall apart about the time you touch it, and all of a sudden, you know, there's a big issue. Switching an underground elbow with a stick is really important too, because when we're switching, we've increased that distance. Now, again, too, the arc flash value is figured at 18 inches. Now, if I get on the end of an 8-foot stick, so what have I done? You know, I've increased the distance considerably reduce the amount of heat energy that I'll be exposed to for sure. So that's up to your employer. If you've got a lock to lock, gloves and sleeves rule, then so be it. I'd say about 50% of the companies do. Okay. The other ones basically don't have that. They may have gloves to open the door. And then I know some that don't do anything, and I've seen some of my customers and I'm going, okay, I wouldn't do that. And I've also seen other things that I wouldn't do based on my training from Southern Company for years and years. I know I'm running out of time and running long, and I apologize for that, but I do want to address the third point that basically we talked about, and that was substation entry. I find that to be an interesting, very interesting topic, because some companies they kind of dip the whole herd and say, look, if you're going to walk in my substation, you got to have your standard uniform on. Usually that's about a hazard risk or an ARC rated category 2, 8 cal shirt, pants, boots, hard hat, safety glasses, and even if you're not going to do anything, if you just walk in the substation. What does the standard say? We'll go back to the standard in paragraph L. It says at some point, there's going to be a 2 cal exposure. At that point, you've got to have on ARC rated FR clothing. So really it depends on, can I open that gate? Did I inspect it for the grounds, the fence grounds, the yard? Make sure there's no anomaly going on, no strange noises coming out of there. And I'm 50 feet from the power transformer, the breakers, or the regulators, or the LTC. Do I really have to have it on? Not according to the standard. Do you have a policy that requires it? Yes. Okay, well then wear it. But that's the way it is. If you want to look in there, and just especially paragraph 269L4, A, B, C, and D tell you when you've got to have ARC rated FR clothing on. And that's when, you're working on 600 volts, you're exposed to it, or exposed to an arc that can set your clothes on fire, or material in the area that can set your clothes on fire, or there's 2 cal exposure or more. That's the 4 times you've got to have it on. So, this is always, and what you see, and especially in this IP forum, you have all these people, 50 people in there, 50 different professionals, and they work for 30 or 40 different companies, and all the companies have different policies and procedures. They're all based on the 1910-269 standard, but some have a very conservative approach. And then I have 1 or 2 customers that don't require nothing but a hard hat and safety glasses to walk in a substation and walk right up to the equipment, as long as you don't operate the equipment. If you're going in there to operate the equipment, that's a total different story. So just bearing in mind, knowing, what the limits are. And then one last thing, this subject always comes up too, about the exposure of face shield. When do I wear a face shield, or when do I just wear safety glasses? Well, that's pretty much spelled out in paragraph L also. Okay. Single phase open air arcs, from 4 to 8 safety glasses. Okay. And then if it's above 8 to less than 13, I always say 12.9. Because of the testing on, an ARC rated 8 cal shield and a balaclava will protect you up to, even though it's a hazard risk category 2 or an ARC rated category 2 shield, it'll still protect the face up to 12.9 cal. Now, if it gets over that, you got to go into a hood and then go into a full suit at 25 to 40, and then even more, and some of my friends down in South Florida that have 80 cal exposure in some of the network vaults down there, they have a 100 cal suit. So you can dress for the occasion. And like the old saying goes, if you're in Rome, you need to dress like the Romans. Okay. And you cover up, that's the last point. The only thing it doesn't have to have ARC rated FR clothing on is your feet with leather boots, your hands with rubber gloves, leather rubber glove protectors, either calf skin or goat skin, and then your head with a hard hat. Of course, safety glasses, polycarbonate 87.1 safety glasses up to about 8 cal. And from that point on, it gets with face shields, balaclavas, and then hoods. Well, that's a lot of information. I think I've probably run I didn't actually get a time when we started, but I don't want to really go over. And it's like I told the class I did yesterday. I said, it's like getting a sip of water out of a 2-inch fire hose. I'll drown you if you're not careful with information. I don't mean to, but I try to cover as much as I possibly can in the length of time I've got to talk. And I love to talk about this. And certainly, if anybody has any questions after they listen to this and they want to call or email, I think Nick's going to put a contact in there, and they'll have my email address and my phone number. So feel free to call or email. And I promise, my phone's went off twice since I've been doing this. So trust me, it goes off all the time. Lastly, I had mentioned before in podcasts that I was writing a book, and I have finished the book. The book is now published. It will be the Kimball, the ebook is already out and people's read it and say it's pretty good. I said, well, I'm glad you liked it. But basically, it's a series of short stories of things like we're doing right now. It may be a 5-minute story on an ice storm or a hurricane or how I learned not to do something. And then even when I had a flash one time it was June of 1973 when I had a flash that convinced me that distribution cover-up was very, very important, and I should really analyze the job and do it right. And I learned a lesson. It didn't hurt me too bad, but it hurt my feelings, believe me. And it embarrassed me. It really did, because, that's another whole story that we may talk about another time. But anyway, the book is out. The published version, the paperback version, will probably be on the market right after the 1st of December. And I'm looking forward to some feedback from everyone out there that gets the book. If you see fit to get the book and read it, please let me know what you think about it, because I really do, because I'm actually writing the second book now. The first book started when I graduated high school and went to work at Georgia Power. And then when I made lineman, I went through my lineman days till I made supervisor. And then the next book will be from lineman to leader. And that's when you go to supervisor, manager, safety trainer, and then safety consultant, which I retired at from Georgia Power. But thank you for listening. I appreciate it. And any feedback from this or any other podcast would be well appreciated. And with that, I'm going to wish you of course, right now it's in November. So I'm going to wish you happy holidays, and hope you have a lot of turkey and get you a nap and watch a lot of football. Maybe you won't get too many trouble calls, but God bless you. Take care of yourself, and I'll see you again another day.
The views, information, and opinions expressed during this podcast are solely those of the individuals involved and do not necessarily represent those of Utility Business Media and its employees. It is strongly recommended that you discuss any actions or policy changes with your company management prior to implementation.